Hello everyone, Professor Wolf here. In this video, I want to cover questions 10 through 21 from the first in-class assignment for my Introduction to Philosophy class at College DuPage in fall 2025. If you're watching this video, I presume that you are a student currently enrolled in one of the two sections of Introduction to Philosophy that I'm teaching at College DuPage in fall 2025. A little bit of background. A few semesters ago, I decided to implement in-class assignments in several of the units that I teach as part of my Introduction to Philosophy class. So we just finished a unit on logic, arguments, and critical thinking, and there was an in-class assignment for that unit. There will be a happiness unit shortly, and we will have an in-class assignment for that unit. That unit will be followed by one on ethics. We may have an in-class assignment for the ethics unit. Then we'll have a unit on free will. There will definitely be an in-class assignment on that unit. We'll have a few short units after that. Probably no in-class assignment for any of those. Our last main unit will be on philosophy of religion, and there very well may be a short in-class assignment on that unit. Here's the situation with the in-class assignments. I give you a list of questions at the beginning of the unit. As we work through the questions together in class, whether through lectures, discussions, group activities, whatever, you answer the questions, you write out answers to the questions on the handouts that I distribute. At home, you type up your answers, you answer a few additional reflection questions, and you submit the results online. Okay. So why did I decide to start doing this? Well, I've talked about it in class a bit, and I just want to remind you, there are a few reasons I decided to implement these kinds of assignments. It was a bit of an experiment. I think the results have been encouraging so far, so I plan to continue with it for the near future, but you never know, things might change. But here are my reasons. First, I thought it might help students to follow the unit. So these units, they last for a number of days. There's a fair amount of material presented. Okay. I organize this material typically around questions. I thought if I gave students the questions in advance, that would help them to follow the unit, right? And that's kind of logical, yeah? I also thought it would help them to produce study guides that would be useful for them. I thought it might help students to learn how to take notes in general, a skill they could apply to other classes. Okay, I haven't really tried to assess that particular, goal yet, but there it is. I thought it would help students to deepen their understanding of the material and their engagement with the material, through the questions covered in class and the reflection questions, and that it could help students with their critical thinking and reading and writing abilities, right? So all of that. The only downsides I really anticipated is that it was so structured that it might stifle student interest in the material, and also that it might stifle class participation and discussion because students would be so focused on writing out the answers. My sense is that is absolutely not the case at all. If anything, I think I've seen, greater engagement and, more discussion. I don't know if I can attribute that to the assignment. That could just be coincidence, not causation. But anyhow, there it is. So they're going to be here to stay for a bit. All right, so that brings us up to speed. I guess one other thing I could add, in class, we didn't quite get through all the questions from the in-class assignment on logic and arguments. We didn't get through all of them. We covered questions 1 through 12. We did not get to questions 13 through 21. And this, what I promised I would do is make a video to cover the remaining questions. We could have taken a day away from another unit. That actually could have been okay. I built a little bit of padding into the syllabus, but I wanted us to just move forward. So I promised I'd make a video on this material, and here we are. Actually, just one other thing before we get going on this. So I understand this material on logic. It can, I know it can seem pretty boring. I know it can seem even irrelevant. I know it's not the most exciting material in the world, often for students who are just starting out with philosophy. But the material is really, really important. It's really important not just for philosophy, but really for all of our thinking, all of our reasoning. It is really important. And I do think if we approach it the right way, it can actually be pretty fun and pretty engaging. And I think there are some really interesting payoffs. We'll get to some of those payoffs by the end of this video. I think we already saw some of them in class together. It's not like they're all waiting for the very end of the in-class assignment. We've already seen some really interesting payoffs, but we'll see some more today. However, we're not in class together. I can't have us do activities, together. This is going to be much more business-like. I'm going to try to make it as interesting and engaging as I can as I go, but I kind of plan for this to be more business-like. So here goes. Without further ado, let's just get going. All right. Question number 10. How do philosophers, logicians, mathematicians, and computer scientists define deductive validity? One thing I hope you see here, there's a presupposition to this question. There's a presupposition that philosophers, logicians, mathematicians, and computer scientists define deductive validity in the same way. Well, that's right. They do. There can be some debates about this, but there's a core definition that all these people work with, right? This actually ties back to question number 7. We might review 7. Hopefully that would be brief. But we're on 10 right now. How do they define it? They define it as follows. First of all, they're defining it for arguments. They're saying that an argument is deductively valid. You might say it has the property of deductive validity, but here we often just switch to saying the argument is deductively valid. They define deductive validity as follows. They say that an argument is deductively valid just in case if all of the premises are true, then the conclusion must be true 100%. I'm going to do this a few times. If all of the premises are true, then the conclusion must be true 100%. I want you to notice a few things about this. I alluded to one just a moment ago. The way that philosophers, logicians, mathematicians, and computer scientists are defining deductive validity, it applies only to arguments. You might say, okay, why are you emphasizing that so much? Because in everyday life, we often say that an individual claim, an individual sentence is valid. We say something, we might say, oh, that's a valid claim when we're looking just at the claim without really looking at the argument. Now, actually here, a lot of times what's probably going on, right, is we do have the argument in mind. We're saying that the claim is valid, that it's like good, because we think it's backed by a good argument, some good evidence, some good reasons, whatever, right? So often when we look at an individual sentence, an individual claim, and we say it's valid, often we do have a larger argument in mind, right? But often we are willing to speak as if the claim itself is valid, as if an individual sentence is valid. It's not how you do this in computer science. It's not how you do it in math. It's not how you do it in logic. It's not how you do it in philosophy. We say that the whole argument is valid or invalid. Something else I can add, arguments are either valid or invalid. There's no middle ground. Every single argument, when we apply the type of logic that we're talking about here, and I'll come back to that in a bit, that's question number 7. When we apply the type of logic we're talking about here, every argument counts as either valid or invalid. Here's another related point. A lot of times, computer scientists, philosophers, mathematicians, a lot of times we don't say deductively valid or deductively invalid because it's too long. We just abbreviate it to say valid or invalid. All right. You might be asking yourself, do you have to write down absolutely all of this? No, but I want to give you some context. So you might be saying, what do I have to write down? Just hold on. I'll help you out. I got your back on that. But let's just put this all together again and deepen it. I'm repeating myself because I think it's necessary. I've taught this a lot. This material, it takes a bit to digest. I think it's helpful to hear the definition a few times, to hear it expanded on a few times, to go back and review. And I know a lot of the questions that students have about this definition. There's one big question that I'm going to hold off on for just a little bit. Comes up in one of the later questions, but I'm hoping this helps you to learn this material, and we're going to see why it's so important. We already did a bit in class, but okay. Let's take it from the top. Question number 10. How do they define deductive validity? As follows. An argument is deductively valid. Again, it's for arguments. An argument is deductively valid. We might just say valid. An argument is deductively valid just in case if all the premises are true, then the conclusion must be true 100%. One other quick comment on this before we move on. An argument can be valid even if all of its premises are false. Think of that definition again. If all of the premises are true, then the conclusion must be true. It's not saying the premises are true. This is really hard for a lot of students to get their minds around, and it's not because they're not brilliant. It's not because they're not cut out for philosophy or logic. All of you have some serious philosophical skills. I've seen it. Even people who end up teaching this material at Harvard often struggle with this when they're taking their first logic class. We're going to talk about this more as we go on. Again, there's a whole other question dedicated to this, right? It's what is it really fast? Hang on. Yeah, it's 18. We'll get an 18. Yeah, in 18 we'll get to it. Maybe I should have moved that up, but anyhow, in 18 we'll say a little more about why our brains struggle with this so much and why it's kind of so difficult and so strange for us in a way, right? Though once it clicks forever. But back to 10, the definition of deductive validity, and this isn't just philosophers who are kind of silly, right? It's also our mathematicians and our computer scientists, the very serious STEM people, right? They're not saying an argument is valid if the premises are true. The premises could be all wrong. They could be all false. They're saying that the argument is valid just in case if all of the premises are true, then the conclusion would have to be true, must be true, 100%. That's the definition. And really, all you need to write down for 10 is this. Here's the definition. An argument is deductively valid. So this is what you write down now. An argument is deductively valid just in case if all of the premises are true, then the conclusion must be true 100%. That's it. Now, really quickly, I want to go back to question number 7. This is dangerous. I don't want to spend too much time on this, but it's really quickly, I want to go back to question number 7. What are 3 different senses of the word logic? I want to be really clear here. Again, one thing we see from this question, there are at least 3 different senses of the word logic. You might be able to find more, but there are at least 3. And when we're not in a philosophy class or a mathematics class or a computer science class, we often use the word logic in one way or maybe a couple of related ways that are not exactly the ways that this word's being used by philosophers and mathematicians and computer scientists and all that. That doesn't mean that the mathematicians are wrong. It doesn't mean that people just out and about living their everyday lives are wrong. There's reason. It's okay for a word to have more than one meaning. It's okay. It's totally okay. And it's totally okay for the meanings to have some fuzziness to them, to have some vagueness to them. That's just how language works, right? We might talk about why that is later this semester. It's okay. And there's some connections between the ways. Often there's some connections between the ways, mathematicians and philosophers are using these terms in kind of like quote unquote ordinary everyday people, or just it could be the same people in ordinary everyday context, right? There's some connections between them. There's this reasons why the mathematicians, the philosophers, etc., they want to take this everyday word we're using and just sharpen it up a bit. And they might want to sharpen it up in different ways for different contexts. And as long as it makes sense what they're doing, it's fine. It's no big deal, right? But just quick review of 7. If you're just out and about in the world, living your everyday life, and you hear people use the word logic, what do they typically mean by it, right? So what we often mean by logic in this everyday, ordinary everyday context, we just mean thinking, or more specifically, reasoning. And how does reasoning differ from thinking here? We talked about this a bit in class. The idea is that with reasoning, we aren't just thinking. Reasoning is a kind of thinking, but there's lots of kinds of thinking that aren't necessarily reasoning. That with reasoning in particular, what we're doing is drawing conclusions from premises. And remember, an argument is a set of sentences, which we can divide into 2 sets, premises and conclusion, where the premises are intended to establish to some degree, support to some degree. We might even use the prove word, prove to some degree the conclusion. The premises give us evidence for the conclusion, reasons to believe the conclusion, support the conclusion, establish the conclusion, prove the conclusion at least to some degree, etc. Okay? So reasoning then is just like argument-based thinking. It's drawing conclusions from premises. They could be conclusions about what to believe, right? What you believe is true or likely true. This is theoretical reasoning. Or conclusions about what to do, how to act, often called practical reasoning, right? So a lot of times in ordinary everyday contexts, when we use the word logic, we're just talking about thinking, or more particularly reasoning, could be theoretical or practical, about what to believe or what to do, right? That's it. And we may have some kind of standard in mind for that, but often when in everyday context, we're not presupposing that there's just one standard for what counts as good reasoning, right? We're often not presupposing there's just one standard. Often we're allowing there could be lots of different standards, and often we're pretty fuzzy about what those standards are, right? And this real quick point on that, sometimes it seems, at least seems to me, that when people use the word logic in ordinary everyday contexts, sometimes they're using it in such a way that they won't even call something logic or logical unless they judge it to be good reasoning. So they might hear someone present an argument and say, that's not logic, that's not logical. And there it seems, at least a lot of the time, they're saying that the reasoning doesn't count as logic or logical because it's not good enough. But in other contexts, we'll say, that's bad logic. Now, maybe in some of those contexts, we could go on to say, and so it's not really logic at all. And then we're back to presupposing to count as logic at all, it's got to be pretty good reasoning. I think there's plenty of times where we actually allow that logic can actually be bad, right? Like it can fail. That's totally okay for us to talk in all these ways. There's no problem with that at all. We just want to do our best to understand what we're saying, as much as we need to for our context, right? That's it. There's nothing wrong with that, right? So again, question number 7, what are 3 different senses of the word logic? Well, one is just any type of reasoning, or maybe any type of good reasoning, okay? What were the other 2 senses? 2 was any system of deductive reasoning, and 3 was a particular system of deductive reasoning. And it's like, well, what does that mean? What does deductive mean? It means deductively valid, right? So even though in everyday life, we often will use the word logic, right? We'll use the word logic for any kind of reasoning, or any kind of reasoning we judge to be good. It doesn't have to be deductive, right? When philosophers and mathematicians and computer scientists, logicians start talking about logic in their classrooms and in their research, their minds often go to deductive, specifically deductive, only deductive types of reasoning. Basically, they're looking at deductive arguments, deductively valid arguments. And so anything that isn't deductive for them doesn't count as logic, right? Okay, let's just slow down for a bit. You probably have some questions in your mind right now. You might be saying, okay, are there any good non-deductive arguments? Yeah, there are. There are lots of good non-deductive arguments. And in everyday life, a lot of the arguments that we call logical, even when we're using logic only for good arguments, a lot of the arguments we'll call logical, we'll say are good logic. They are not deductive. They are not deductive. We could put that by saying they're non-deductive. Now, if you go a little further with this, you might say, wait a second. So deductive arguments are deductively valid arguments? Yeah. And all arguments are deductively valid or invalid? Yeah. So any argument that's not valid is invalid? Yeah. And those are non-deductive? Yeah. So there are good arguments that are non-deductive? Yeah. So there are good arguments that are invalid? Yeah. But how can that be? Invalid means bad, doesn't it? It's complicated. That's question number 18. Okay. Let me just review this again. I know we can feel like we're a bit in the weeds. I know you can feel overwhelmed. I know you can feel like this is confusing. You can stop the video. You can rewatch it. I think this is actually a good reason to have this on video. You will get this. If it takes you a little bit of time, that's all right. I guarantee all of you will get this before I did when I was your age. It is a bit complicated. In everyday life, we will say, hey, that's logic, or hey, that's good logic, for all kinds of arguments, including ones that don't count as deductively valid. Okay? And one way you might be able to see how that makes sense if we go back to our definition of deductive validity really fast. If the premises are true, then the conclusion must be true 100%. Now maybe you could start seeing it. Could just ask yourself, do all good arguments give you 100% guarantee that the conclusion's true if the premises are true? In order for an argument to count as good at all? Right? You have to have 100% guarantee. Now you might say, no, that's too strong. That's too strong. Yes, it is too strong. You're right. Great. It is too strong. It'd be way too strong to say the only good arguments are ones where you have 100% guarantee the conclusion's true if the premises are true. Way, 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 way too strong. Way, way, way too strong. Way too strong. There's going to be good arguments that don't pass that test. So they're good, but they're not deductive. And I know they're good, but they're invalid. And at this point, your question maybe now becomes, well, why on earth would you take the word valid, that just means good, and then apply it only to the super good arguments? You're kind of implying then everything that isn't super good is just bad. But it's not. It can be good, just not super good. I hear you. I didn't make the rules. This is decided by mathematicians and computer scientists and philosophers before I came along, and there are kind of some reasons for doing it. We'll see. But okay. So to tidy this up, and can I add a little more and just pull this all together, and we'll move on, and we can get through the next questions much more quickly. Right? Take up the thing I just said. You might say, why would mathematicians and computer scientists and philosophers, why would they focus only on the super good, only on the 100% arguments, and kind of ignore everything else? Well, in math, we do expect things to be 100% or zero, right? Either, this conclusion follows 100% of the time from the premises or not, right? That's basically how math works. At least all the math we're familiar with, right? In computer science, it's the same thing, right? If you put input into a computer, now maybe the program has got a bug in it or the hardware breaks down or something, but in computer science, you want the computer to follow very, very precise instructions, right? If you give it this input, you want it to give you this output 100% of the time, right? At least a lot of applications, okay? So kind of makes sense there. And there's reasons in philosophy to ask whether we could achieve the same standard across all sorts of different domains, God, free will, you name it. There might be plenty of times in philosophy where we say, well, the arguments aren't really quite that strong, but they're still pretty good. We accept them. Okay. But if you look at math and computer science, you see why there's reasons to focus on these types of arguments. And I just mentioned philosophy, you could see reason for that too. In science, kind of same thing. There, in science, maybe a lot of your arguments aren't quite 100%, at least the ones that aren't totally math-based. But it can make sense to look at that. And just more generally, right? If we're trying to figure out let me rephrase. If you're trying to figure out what counts as a good argument, what counts as a successful argument, right? And you're trying to look at to what extent do the premises need to support the conclusion for it to be a good argument. It does make sense to start off by focusing on the cases where the support is 100%, where you have 100% guarantee that if the premises are true, the conclusion's got to be true 100%. It makes sense for a lot of reasons. What I'm trying to say here is it makes sense for a lot of reasons to focus on those types of arguments. You just, at some point, you're going to have to focus on other stuff too and ask how it all fits together. You're going to have to do that. But also, it turns out to be really difficult to work out the theory of 100%, which of course, and so it turns out that even in this mathematical logic, this computer science logic, there's all sorts of philosophical questions about it, right? And that was question number 9 on the assignment, which I'm not going to review. But it just to move on, here's a tie between 7 and 10, 7 and 10, 7 and 10, question 7 and 10. What are 3 different senses of the word logic? 1, just any kind of reasoning or good reasoning. That was 1. 2, any old system of deductive reasoning. That is theory of deductively valid arguments. 3 was a particular theory of that. Okay? A particular theory of that. And as we talked about in class, there are different theories. There are different theories out there of which arguments count as deductively valid and not, right? That's the second sense of logic would just be any old theory, any old system of deductive reasoning, as any old theory, any old system of deductive arguments. 3 the third sense of logic in question number 7, a particular system. As I said, there is a particular system, a particular theory. We often call it classical logic. Classical logic. And as I may have said in class, classical might make it sound like it goes back to Aristotle, but no, it's much more recent, right? This theory starts being put together in the late 1800s and is, pretty much completed, in my sense, within a couple of decades, by like, maybe the mid 1900s, something like that's pretty much done. That's my sense. This system we're calling classical logic, right? There's actually like two kind of halves to it. One is we sometimes call propositional logic or elementary logic, or I sometimes hear it called baby logic. The other part we often call predicate logic or quantificational logic or first order logic. We just put it all together. We often just call it classical logic. It is a very specific system. It's a very specific theory. It's not just focused on deductively valid arguments. It's much more specific than that. It's telling you these are the specific arguments that are deductively valid. These ones, and that's it. Okay. And it makes all kinds of assumptions about the nature of those arguments and the sentences that make them up, and how you build up those sentences and everything else. So it's a very specific theory. I showed you books, about it in class. Okay. So that's 7. Connecting this back with 10, deductive validity. This is deductive reasoning. This is systems of deductive reasoning, right? That classical logic is basically a theory of deductive validity. It's a specific theory of deductive validity. All right. I hope all of that was clear enough. You can rewatch. You can ask me questions about it. I told you exactly what you need to write down, right? I could cover this more in class later, future videos if anybody needs, but let's move on and get through the rest of this much more quickly. So question number 11, and we did this in class. What makes a deductively valid argument deductively valid? How can any argument have such an incredible property? So if deductive validity means that if the premises are true, the conclusion's true 100%, guaranteed, absolutely. How can anything be 100%? How can anything? Well, a natural way to think about this is form, right? Form, or you could call it structure. And that's what I want you to write down, right? For 11, what makes a deductively valid argument deductively valid? It's form. You could also say it's structure. For us, these are the same. Form, structure, form, structure, form, structure. What makes it valid? It's form or it's structure. How can any argument have such an incredible property? Because certain forms or structures have this incredible property. Certain forms or structures have this incredible property. So I used an example in class. I'm going to give you another one. See if you can get this. A equals B, B equals C, therefore A equals C. We have 3 sentences here. There's 2 up top, on top of the bar. Those are the premises. There's 1 below the bar. That's the conclusion, right? I can number all this to make it a little clearer. We number the premises. A equals B, premise 1. 2, B equals C, conclusion, therefore, A equals C. This is the form. This is the form. And why are we calling it a form? Because I don't have any specific names here, right? We could substitute for the A, B, and C. These are variables. We could substitute specific names. I could say something like, Kal is Clark Kent. That's 1. 2, Clark Kent is Superman. That's 2. Conclusion, Kal is Superman. Right? I could do something like that. I could put in, Jim is Bob. Bob is Kevin. So Jim is Kevin, right? You can write in whatever you want. And the idea is this, right? When we write things in for A, B, and C, it may be that what we get for 1 and 2 are true. It may be that what we get are false. But we would know that if 1 and 2 are true, then the conclusion would have to be true 100%. And why? Because of the form. Let's look at this a little more. I'm actually going to switch this up a little bit. So here's a very famous argument. Here's a very famous argument. All humans are mortal. Mortal means they're going to die. They're going to die. Socrates is human. So Socrates is mortal. My handwriting's a little bad, but here it goes. 1, premise 1, all humans are mortal. 2, Socrates is human. Conclusion, Socrates is mortal. Now, when you look at this argument, and when I tell you, what mortal means, you say, okay, yeah, 1 is true. You're like, yeah, all human beings die. Yeah, that's true. And then you look at 2 and you say, yeah, Socrates is a human. And you get that from 1 and 2, the conclusion follows, and it follows 100%. If the premises are true, that conclusion's gotta be true, 100%. It would be impossible, utterly impossible, for the premises to be true and the conclusion to be false. This is a valid argument. Here, the premises are true. But we could isolate the form, and here's the form. The form is, we might say, all F's are G's. And then we have 2. Let's say X is an F. I'm sorry, my handwriting, it's not going to come through clearly. And then we get for our conclusion, X is a G. X is a G. Sorry for my handwriting, and I did a little scratching out. So if we look over here at, it's comical how bad my writing is. All humans are immortal. Socrates is human. Therefore, Socrates is mortal. There's a form there, a form. What do we mean by the form? It's like a structure that this argument can share in common with certain other sets of sentences. So what is it? The form is all F's are G's, X is an F, X is a G. Now, to help you understand what a form is and to help you understand what we're talking about a little more in general, what could be another example of this? How about this? All vegetarians like tofu. Susie is a vegetarian, therefore Susie likes tofu. We have the same basic form. All F's are G's. We're making a general claim about, like, you might think of it like this. Here's one way you can think about it. We're saying that, like, one class of things is included in another class of things. Like all the humans are mortal, right? Anything that's human is mortal. Anything that, like, falls in the first class falls in the second class, right? So all humans are mortal. Right? All vegetarians like tofu. All the vegetarians are in the liking tofu category, right? And then what we're saying is now we've got one example of something in the first category, human vegetarian. Well, then it's got to also belong to the second category, mortal or likes tofu, right? We could do another one. Everyone born in Chicago is a Chicago Bears fan. Wolf was born in Chicago. Therefore, Wolf is a Chicago Bears fan. You can do this to the cows come home. All unicorns are vampires. Bob is a unicorn, therefore Bob is a vampire, right? You could just do this to the cows come home. You can make up all kinds of arguments, right, that all have this same basic form. And now here's the thing. Some of the times, everything you say is going to be true, right? All humans are mortal. Socrates is human. He is mortal. Absolutely. Sometimes what you say, it might be all false. All unicorns are vampires. Let's call that one false, right? Michael Jordan is a unicorn. False. So Michael Jordan is a vampire. False, right? Sometimes what you write down, it'll be all true. It'll be all false. Sometimes it'll be a mix. It all has the same form. Now go back to all humans are immortal. Socrates is human, therefore Socrates is mortal. That's valid. You can just kind of see that intuitively. If the premises are true, then the conclusion's got to be true 100%. Why? Because of the form. It's the form doing the work. Because again, what is that form basically saying? It's saying that whenever you've got two groups of things, such that everything in the first group is in the second group, okay, then take anything in the first group, it will also be part of the second group. That's really all the form is saying, right? And when I lay it out like that, I think you could see a few things. One thing is, you can see it. It's almost like our mind just has like this connection with truth. It's sound kind of mystical, kind of weird, right? And so a lot of philosophers start kind of getting anxious about this, but then we want to come up with some less mystical like version of the story to tell, which makes sense, right? But it's almost like our minds can just see that this form is valid. You might have said 5 minutes ago, 10 minutes ago, how could any argument really be 100%? How could anything be valid at all? This looks valid, y'all. It looks like it's 100%. You might even say it's just what the words mean. It's just what the concepts mean, right? And you might say that even if there are no triangles in the real world, even if you were in a verse, a part of the multiverse, by the way, do not believe that thing is real, right? If you were in a part of the verse that had no triangles in it, you could still say, well, if there were triangles, all our geometry would apply to it, right? This is where I'm moving into the second thing. You can see that you can make sense of how if the premises are true, the conclusion's got to be true no matter what you plug in. Now, it could be that you plug in some material that isn't true. All unicorns are vampires. That's not really true. Michael Jordan is a unicorn. That's not true. Michael Jordan is a vampire. That's not true. Everything there is false, but the argument is still valid. It's still valid. And why is that? Because if the premises were true, the conclusion would have to be true. If unicorns really were vampires and Michael Jordan really were a unicorn, let me go back and do that again, just to make it a little clearer. If all unicorns, if there really were unicorns, right? I'm kind of doing this in a way it's a little bit different than the way we actually do it in logic, but here it goes. It's fine for us. If there really were unicorns and there really were vampires and each and every single unicorn really were a vampire and Michael Jordan really were a unicorn, he would have to be a vampire no matter what. He would have to be. And you might say, yeah, but that stuff isn't true. But here's the thing again, validity is not really focused on what is true. It's not really focused on truth in that sense. It's trying to figure out what kind of supports would be 100%. What kind of inferences would be 100%. It's trying to figure out when you would have 100% guarantee the conclusion is true if the premises were true. Right? That's what we're focused on. I could say more about this, but yeah, let me actually say a little more about this now. I think it'll really help out, and then we can really get through the rest of the questions really quickly. So here's one way you might want to think about this, right? Take the argument again. All humans are mortal. Socrates is human, therefore Socrates is mortal. We see here the premises do support the conclusion really strongly. It's 100%. If the premises are true, conclusion's got to be true 100%. How do we know that? I said it just seems blindingly obvious, but let's go a little bit beyond that. We might say it's just the concepts, it's just the words, it's just what they mean. You can start putting some pressure on that. You might want to offer an alternative explanation, but let's just let that be what it is, right? That's that argument's 100. That's 100%. The logic's 100%. The logic's 100%. The logic's 100%. If the premises are true, conclusions got to be true. Premises are true, conclusions got to be true. Premises are true, conclusions got to be true. Right? Okay. Now we can identify a form there. All F's are G's. X is an F. X is a G. We can extrapolate that form. And we can plug in other stuff for that form. Stuff like all unicorns are vampires, Michael Jordan is a unicorn, therefore Michael Jordan is a vampire. The content is no longer good. The premises are no longer true, but it's the same structure. It's the same argument form. And it does follow that if the premises are true, the conclusion has to be true 100%. Now, again, you might just say, yeah, but the premises aren't true. Why do we care about this then? Here's no way you can put it, right? If, and actually, what I'm actually doing is I'm kind of going ahead to 18. I'm just, because I think it'll just help us to do this now. We're just going to go ahead to 18. You might say to yourself, look, okay, I get that the Socrates argument is really good, but the Michael Jordan one is really bad. So why do we care then about what we're calling validity? And why should we call it validity at all? Because doesn't valid mean good? Doesn't validity mean good? So how on earth could these mathematicians and computer scientists and philosophers use this term valid, this term validity, which means good? How could they apply them to these arguments that are bad? Go back to the Michael Jordan argument again. It is a bad argument, but it is also a very good argument. It's both at the same time. And you say that's a contradiction, and the thing is, no, it's not. It's not. It's not a logical contradiction. Things can be good and bad without logical contradiction as long as they're good and bad in different ways. Right? If we go to Dairy Queen, okay, and we get the pumpkin pie blizzard, which I think is back now, y'all, and I take a bite of mine, and you say, how is it? And I say, it tastes great and it tastes bad. Well, even that maybe is not a contradiction if I'm talking about different ways it tastes. You know what I mean? Like maybe I mean like the ice cream's really good, but the pumpkin flavoring is really bad. Good quality ice cream, bad quality pumpkin flavor, right? Then actually it makes sense what I said. But suppose I just say the pumpkin taste is really awesome and it's really terrible, right? Okay, that I think we're pretty much in contradiction territory now. But what if you say what do you think of the blizzard? And I say it tastes great, but it was kind of expensive. So I'm saying the taste is good, but the price is bad. Well, that makes sense. There's definitely nothing approaching a contradiction there, right? Go back to the Socrates argument. We have a form. All F's are G's. X is an F. Therefore, X is a G. That form is amazing. Whatever you plug in for it, whatever content you plug in, if the premises are true, the conclusion's got to be true 100%. That's 100% support. That's the best you could possibly ever achieve. That's one of the best kinds of arguments you could ever get. The form, that is. The form is amazing. The form is amazing. The form is amazing. It gives you 100% guarantee that the output is true as long as the input is true. Okay? Now go over to the Jordan argument. Right? All unicorns are vampires. Jordan is a unicorn, therefore Jordan's a vampire. The same structure, the same form, so it's still got to be great, and it is. If the input is true, the output's got to be true 100%. But you say here, but the input isn't true. It's false, even wildly false. Michael Jordan's not a unicorn. Yeah, you're right. So the Jordan argument, in a way, is very bad. It's very bad. Two premises are both false, wildly false, ridiculous, absurd. And then you might say, well, if the argument has got, false, ridiculous, absurd premises, then it's just got to be completely bad in every way, right? No, the structure is still good. It's the same structure as the Socrates argument. Structure's amazing. The content's bad. And now here's the thing. What we want out of an argument is not just one thing. We want two things. If the whole point of these arguments is to figure out what's true, right? To figure out what's true, we need two things from an argument for truth. We need for the inputs to be good. We need for the content to be good. We need for the premises to be true or likely true. And then we need the form to also be good. We don't just want one thing from an argument. We want two things, right? We want the premises to be true or likely true. And then we want the form to be good, right? We want the form to be good. We want the form to be strong. A way we can do this is we've been talking about like form and structure is one thing. Now I'm starting to talk about content. Content is like what you plug into the structure, what you plug into the form. For a good argument, we need a marriage of form and content, or you might call it structure and content. We want the premises to be good, but we also need the premises to provide strong support for the conclusion, right? Let me skip around a bit to help cement all this. 19, is it possible for an argument with all true premises and a true conclusion to be bad? Yeah, of course. What's an example? Here it goes. Basketballs are round. Conclusion, the earth is round. It's all true. And by the way, when I say round, I don't mean a perfect sphere. Let's not, sometimes we just get ridiculous the way we focus on words, right? I think part of being a good critical thinker is kind of understanding the level of precision you're trying to achieve with all this, right? So if I say, how about I do this? I'll have two premises and one conclusion for my argument. Premise 1, basketballs are round. Premise 2, grapefruits are round. Conclusion, earth is round. The premises are true and the conclusion's true. Basketballs are round. Grapefruits are round. The earth is round. It's all true. What's the problem? The premises don't provide any support for the conclusion. Now, I could add a premise that I could do this kind of argument. Basketballs are round. Everything has the shape of a basketball. The earth is a thing. Therefore, earth is round. Now that argument's valid. That argument's valid. If the premises are true, the conclusion's got to be true 100%, right? But now I've added in premises that are obviously wrong. Yes, basketballs are round, but it's not true that everything has the shape of a basketball. When I add in that premise, everything's got the shape of a basketball. Now I make the argument valid, but that premise is just ridiculous. It's false. It's absurd. So now I've got false premises, right? But if we go back to the original argument, basketballs are round, therefore the earth is round, or basketballs are round, grapefruits are round, therefore the earth is round. Nothing there is false. That is all absolutely true. But there's nothing to connect the premises with the conclusion. And if you reflect on this, what you see is this. When it comes to an argument, so focus on the basketball argument. What does that argument teach you? Truth isn't enough for a good argument. Now go to the Michael Jordan argument. What does that teach you? Form is not enough for a good argument. You need both. You want to take the Socrates form and combine it with the Socrates content. You want the good form with the true premises. You want to put those together to get a good argument, right? Okay. We're going to wrap this up seriously really fast. I would like to be done in like under 10 minutes. I know you would too. So, let's just review again 11 really quickly. What makes a deductively valid argument valid? The form. How can any argument have such an incredible property? It's just the form. That's what it is. Just say the form. You can just write the form. If you can add in anything else from this video, that would be awesome, but that's good. Again, we'll skip ahead to 18. Let's just make sure you got that down. If a deductively valid argument might be bad, why call it valid? Because if you look at an argument that is deductively valid, why would it be bad? It would be bad because one or more of the premises are false. Then why would we call it valid? Because the form is still amazing, because it's still a valid form, right? I'm not going to say anything more than that. We're good. 19, is it possible for an argument with all true premises and a true conclusion to be bad? Yeah. I just gave, yeah. If so, why? Because the form could be really bad. The form could be really bad, okay? And that would mean that the premises, even though they're true, don't provide any support for the truth of the conclusion. Don't provide any evidence for it. Don't provide any reason to believe it. There's no real connection between the premises and the conclusion. Give an example. I gave you one. All right, let's continue. How can we test arguments for deductive validity? Name 2 common strategies. So really quickly, I went over this in class. One method is we can just translate it into symbols and just see if the form is valid according to our theory of logic, right? That's one strategy. Translate it into symbols and see if if the form is valid according to our the theory of logic we're working with, which usually is classical logic. What would be another strategy? I called it the imagination strategy or the multiverse strategy. You just kind of close your eyes and you imagine filling out like a whole universe with the premises, and then ask yourself whether the conclusion would have to be true in that world, right? So if I do the Socrates one, so I don't even assume there are human beings. And if there are, I don't assume anything about them. They could be immortal, they could be unicorns, whatever. And then the first premise tells me all humans are mortal. So now I assume that there are humans and that they're mortal, or that if there are any humans, that they're mortal. And then I assume Socrates is a human. So Socrates exists and he's a human. Well, if those are the only things I assume about that world, that universe, is that enough for me to be able to work out 100% that the conclusion is true, that Socrates is mortal? Yeah. What would be another one? One that maybe we could show is not valid by using this strategy. So here's a quick argument. It's December in Chicago. I look out my window before I go to sleep. There's no snow on the ground. I wake up in the morning. There's snow all over the ground. Those are my premises. I didn't number them, but there they are. What conclusion do we typically derive? It snowed during the night. That's not a valid argument. How do we know that? Because we can imagine a scenario where the premises are all true, but the conclusion is false. How would we do that? We'd have to imagine the snow got there in some other way. How could that be? Someone's playing a prank on you, whatever, right? Time is short. We're going to move on. But you can use your imagination in this way. I mean, it really helps to have some logical background, but when you get some logical background, you can also just kind of imagine these scenarios, right? You could, they could kind of show the argument is valid or that it's not, right? So just really quickly, I want to tell you exactly what you need to write. How can we test arguments for deductive validity? Name 2 common strategies. First, translate the argument into symbols and see if the form is valid according to a theory of logic that we're working with. 2, use the imagination or multiverse strategy. And actually, I do want you to say a little more there. I'm going to let you work out what you want to write. All right, 13. How do philosophers, logicians, mathematicians, and computer scientists define soundness? Really fast. They say that an argument is sound just in case it's deductively valid and all the premises are true. That's the marriage of the form and the content. Again, how do they define soundness? They say an argument is sound just in case it is both deductively valid and all the premises are true. That's all you got to write. But you see there, you get the marriage of the form and content, and you see that if an argument is sound, the conclusion's got to be true, 100%, right? Okay. 14, how can we test arguments for soundness? The same way you test for validity, plus you have to have a truth test for the premises. That gets tricky. How do we test for proof? How do we test for truth for anything? Okay. 15, what's an example of a deductively argument that is sound? The Socrates one. What's an example of a deductively argument that's unsound? The Jordan one. 17, are all deductively valid arguments good? Arguments? Well, no. Why? Yeah, I mean, they're good insofar as the form is good, but they could also be bad insofar as the content is bad. What's an example? The Michael Jordan one. You could have a deductively valid argument with false premises, right? Okay, 18, we did that. 19, we did that. We're almost at the end, y'all. 20, are any invalid arguments good? Here's where things get funny. Again, it sounds so weird. Could an invalid argument be good? Yes. Yes, of course. Why? Because again, 100% logical guarantee is just too high to hit a lot of the time in everyday life. Sometimes we get there, but sometimes we don't. A lot of times we don't. Right? I think I used this example in class. What would be a form of valid reasoning that you even see like a dog follow? I'm not saying the dog is consciously going through it, but you could see the behavior of a dog exhibit, and we consciously go through this reasoning all the time. It's a form of argument that goes like this, right? Where's my pen? We're almost done, y'all. 1 hour isn't bad. I'm not going to feel bad about that. All right. We could start, if we have A or B, that means A is true or B is true. Not A, that means A is false. Well, then we would know B is true. A or B, not A, therefore B. If we really know it's true that either A is true or B is true, and we really know that A is false, B's got to be true. If it turns out that A is false and B is false, then we were wrong when we said that either A is true or B is true. But we're assuming we're right when we say that A is true or B is true. So if that's right and A is wrong, and B's got to be true. And again, you can think of these cases where, I don't know, a dog's chasing a squirrel or something, and a dog, like, its senses, tell it that the squirrel went one way or the other, and then it kind of sniffs one way to see if the squirrel went that way, and it sees it didn't go that way. Well, then it knows it went the other way. I mean, that's valid reasoning, right? There's all kinds of examples of valid reasoning we use in everyday life. We do use it. It's not that we never use it. We do use it. We may not have 100% guarantee the premises are true. You might even say we don't have 100% guarantee that any of these things are really valid, but we do reason validly all the time about all kinds of things, right? Here's another really trivial example. This is super trivial, right? If A is true and B is true, well, then B is true, right? A and B, therefore B. If A is true and B is true, well, B is true. That's kind of just what we said in the premise, you might say. So sometimes somebody will say, yeah, I went to the store and I went to the dry cleaners. And then later someone says, did so-and-so go to the store? Yeah, because we went from A and B to A. We do that. We do that kind of stuff, right? So we are surrounded by valid reasoning. Some of it's actually pretty uninteresting. It's kind of hard to get a lot of really interesting valid reasoning, really interesting 100% stuff, but we do that too, arguably, So the thing is, though, is a lot of our good reasoning is not valid. And I'm not going to write all this out and show it to you, but let's give 2 quick examples, which we might discuss further in class, and then we'll be done. And I think this is where things start to really get interesting and really heat up a lot. Though I think we've actually seen a lot of interesting stuff so far. So you all learned in school that a meteor killed the dinosaurs, right? Where did that come from? There were 2 scientists named Alvarez and Alvarez. They were a father-son team. The son was a professor of geology, I believe, at Berkeley for many years. I think he retired a few years ago. I think he's still alive. His father was, I think, a physics professor at University of Chicago. And the son started doing this work on core samples. He's a geologist, right? And he notes that there is this spike, relatively speaking, there's this spike in iridium. Iridium it's an element, it's on the periodic table, right? It's fairly rare on Earth. So when you're looking at core samples, like samples of, digging down into the Earth from like 70 million years ago, you see I guess basically no iridium. When you look at samples from like 50 million years ago, you see basically no iridium. But 65 million years ago, there was an appreciable amount of iridium in core samples taken from around the world. Well, where did it come from? Right? If the iridium was always there, well, then you should have seen it before, but you don't. Right? And why don't you see it after? We don't think these kind of things just happen for no reason. They come from nowhere. So where did it come from? Well, Alvarez knew that meteorites, like space rocks that hit the Earth, it's not so rare for them to contain iridium. Okay, so iridium is like really rare on Earth, but not terribly rare when it comes to meteorites. Okay. He also knew that for a meteorite to deposit iridium around the Earth like that, it'd have to be pretty darn big. He also knew a meteor that big would have pretty big impact on the Earth. He also knew that dinosaurs went extinct 65 million years ago. He also knew that an extinction event of that size, or at least he believed, I think we'd all agree, doesn't happen for no reason. It's got a cause. He also knew a meteor, right, big enough to leave the iridium could cause that kind of extinction event. He put it all together. He concluded a large meteor, I think we call it meteorite once it hits the Earth. I don't know. Is it a meteor when it's flying through the sky? Whatever. That a large meteor or meteorite containing iridium struck the Earth 65 million years ago, triggering this extinction event and leaving these iridium deposits on Earth. It is a really, really, really good argument. And we found a lot more supporting evidence for it. A lot more supporting evidence for it, right? It's a really good argument. I think it's a beautiful argument. I tell my students I'd put that in the argument museum. If I won the Powerball someday, I'd have a logic museum. I'd put that in there. It's not a valid argument. It's not valid. If you write it up in symbols and try to extract a form from it, you're not going to find that in any logic book. It's not valid. Technically, then we would say, according to the standards of that logic, it's invalid. That makes it sound bad. It's actually great. It's just not 100%. So be it. Right? Actually, for 20, I would like you to use that Alvarez and Alvarez argument. You don't have to try to write it all up like I did, but yeah. And actually, when it turns out, when you look all around science, like when you look at Darwin's argument for natural selection, basically what we call evolution. There were other forms of it before, but whatever. Okay. When you look at Darwin's, evidence, his argument for evolution, it was not 100% reasoning. When you look at, Copernicus's argument for the Earth being the center, the Earth not being the center of the universe, right? And I think he actually thought the sun was the center of the universe, which is also wrong. It's the center of the solar system. But, when you look at all these types of a lot of these arguments in science, they're not valid. That doesn't mean they're worthless. A lot of times they're very good. They're just not 100%, right? And actually, I would argue, I think a lot of philosophers would argue at the end of the day, ultimately, all of our reasoning is invalid. And we can't have purely valid arguments for our theory of validity, right? Like, there it is. And so 21, what does the answer to 20 reveal about the limits of classical logic? The specific theory of deductive reasoning that was the third sense of logic back from question number 7, the theory of logic that, mathematicians and computer scientists and philosophers often have in mind when they talk about logic, mathematical logic. It's very limited. It's a great tool, but it's limited. It's like if you have a really great hammer, you can do a lot of stuff with it, but you can't do everything. You might need a saw and you might need some other things, right? You might need different kinds of saws, right? 100% guarantee only gets you so far. And then we could actually ask, can we be 100% about our theory of 100%? But even setting that aside, even if we're really confident, like really, really confident, that certain argument forms are 100%, in other words, that they're deductively valid in our technical sense, which I think we can be really confident of that, lots of stuff is not going to pass that test. It's not going to pass it. So we're going to, even a lot of stuff in science is not going to pass it. So we're going to need more. The thing is, there's already a lot of philosophical questions, hard ones about classical logic. Once you start moving into other forms of reasoning and start asking about what are good forms of non-deductive reasoning, a lot of murkiness remains. And actually, if anything, it's a lot murkier. Or maybe actually it's just all really murky and we're often just not even seeing the murkiness of the classical stuff. So, and actually it's not just in philosophy this is a problem. It's a problem in science. This last thing I'll sign off. We often talk about the scientific method, and we often talk as if all scientists think the same way. They absolutely do not. And that's why we can have debates in science. Like, Dark matter. Go read about dark matter. We got a number of theories of dark matter right now. Scientists don't agree about which theory is best, how good any of them are, right? They don't think the exact same way about everything. Of course they don't. And and when they disagree, that reflects that they have disagreements about what counts as good reasoning or better reasoning or good enough reasoning. I'm not trying to say that science isn't amazing, right? I'm not trying to say we should have skepticism about it. We're often so dichotomized and polarized. It's like we say, if it's not 100% absolutely proven, irrefutable, indubitable, infallible, then it's just opinion. No, there's a lot of gray. And then we'll say, no, the gray's just in philosophy. Math is gray free. Science is gray free. No. And then we might just say, well, then everything's on the exact same level. No. And maybe not everything in science is exactly on the same level, or even everything in math. There might be areas of math that are more certain than others. If that doesn't make sense to you, go Google large cardinal set theory, right? All right, y'all. Signing off. Thanks for hanging in there.